This, I hope, will be our last lecture on section 1.5 and therefore for chapter 1. We're talking about the elements of good design, and we're going to talk about the two types of designs. We are talking about observational and experimental. So let's again just review the elements of good design. First of all, whether you're doing an observational or experimental study, correct sampling, right, is always very important. We've talked about the sampling exclusively for nearly one of the lectures. The elements, remember, is to define your question, and based upon the question, the population that encompasses the question that you have. And then a good plan to collect that data. And with the experimental design, the plan for collection, we're going to talk about some of the elements there in even more detail. And then after we collect the data, being aware of some of the pitfalls that could have occurred and could have led to incorrect interpretations, incorrect results. That is important to know as well. And then when you analyze and draw your conclusions, being able to have pinpointed sources of error and problems that could have occurred, and being able to tell others about those potential sources and how what they're seeing may not actually be everything that's there. So that's designing a good experiment or a good observational study. So we've talked almost exclusively in class and also in the lectures here on video about observational studies. So observational studies, they observe and measure specific characteristics with no attempt to modify the subject that's being studied. So you're not trying to change anything, you're just getting information. So that is like a survey. Now the other type is an experiment. An experiment actually tries to apply a treatment to elicit a change or a response. So an experiment is defined as a treatment being applied and then observations being made on the effects. Experiments are something like a migraine medicine being given to migraine sufferers and then observing the results, maybe measuring the intensity of the pain on some scale that's been scientifically proven to interpret migraine pain. So that would be an experiment. And so we're going to talk about, first of all, a couple of types of observational studies, and then we're going to go ahead and talk a little bit more about experimental design that does a lot of times encompass an actual experiment, not just observational. So types of observational experiments are cross-sectional, which is the most common, and that's just at one point in time we take observations. That's what means cross-sectional, right? So if you've got a tree here, right, and you have this tree and you cut a cross section of it, well, you're just seeing one point in time what that looks like, or one place in the tree what it looks like, and that's what that means. It's a cross sectional, it's done at one point in time. Then the retrospective and case controlled retrospective, meaning that we're looking at a certain cases. We are going to get information by interviewing or by going through records about something that happened in the past. Now, prospective or a longitudinal cohort study, those are, we're going to collect the data from the groups throughout a period of time. And usually with a prospective study, we're looking for some kind of cause and effect type of relationship. So the retrospective might want to do something as far as finding out, you know, the length of time that people lived who were smokers in the 1800s. And then that might actually be compared to some data at this point in time to make the distinction between the differences. But somebody or people who lived in the 1800s, we're not going to be able to actually get information from them. It's going to have to be from past records. So we'd either have to interview people that knew someone that lived in the 1800s, or we would have to have records to that effect. The prospective, and a lot of times these are done in medical studies where we actually get get information right here and now, and then we study the same individuals over a certain time to see what is happening. That can be done in an experiment in the way that we have the person comes in and maybe they have a disease, right? And then they apply a treatment, and then the observations or the observations are made again, and then maybe after the experiment is done on them, then later on they go and come back and they see how things went after a time. So these kind of studies can be done to show a case study through time of how maybe a treatment being applied had affected the person or the question being asked, but also it could be done just as simple observational. So how has a child grown over their 18 years? So you observe them at birth, and then observe them at a year, and then observe them at 5 years, and then observe them at 12, and then observe them at 16, and then observe them at 18. And then you have these little snapshots, and that's what a longitudinal or cohort study is. Now, designing a good experiment, first of all, it needs to be well run. And when we design an experiment, we want it to contain both a control group and a treatment group if possible, because we want to know what would happen if there was no treatment applied to someone. And so we have a group of people that all fall under the same characteristics, and we're going to observe them with and without treatment, essentially. And that's what the idea of a control group is. Some of the problems that we run across with designing an experiment where we have control groups and treatment groups is the placebo effect. And that is a change to experimental units. A lot of times we think of these as people. The people, based upon the fact that they believe they're being given a treatment, because control groups very seldom in medical experiments, for instance, are just not given anything at all. They're actually given a placebo, something that they believe has a drug in it. And maybe even the doctors or the nurses that are administering the treatment believe there's something within that contained within the placebo. And that goes into some things called blinding and double blinding that we'll talk about in just a second. And then the other problem that we can have is confounding. And confounding is basically that different factors can affect the thing that's being studied. For instance, we may have someone in a medical study that is practicing yoga while they're doing their treatments. Maybe that has an effect on them, right? So confounding, we can actually break things into different blocks, and then we can apply different agents to them which are possibly going to be confounding. And that's where we get into ideas for block design. Now, the controls that we have for placebo effect is just as I mentioned above. We can have blind and double-blind experiments. And in blind experiments, the groups don't know. So we assign some people to a placebo group and some people to a treatment group. And the people within the groups themselves don't actually know, am I receiving real medicine or am I receiving just a placebo? And the problem with just doing a blind experiment is that sometimes the nurses or the doctors, whoever's administering the treatments, they can telegraph the fact that the person is or is not actually receiving medication. And they can do that just with body language or things that they say inadvertently. It's that whole psychology thing again. Now, a double-blind experiment eliminates that problem as well because neither the people administering nor the groups know which group is which. And so there's no way of telegraphing whether the doctors or nurses really think that a person should be getting better or not. Now, confounding, we eliminate confounding by doing block designs. So there's quite a few different ways of doing block designs. We have what we call a completely randomized block design, and that way we just randomly assign people to groups. And then all the confounding variables should be found within each group in the proportion that they're actually there. And so completely randomized is supposed to mimic the idea that the subpopulations are present in proportion to what's actually existent in the true population. Now, a rigorously controlled is kind of the opposite of that. So in a rigorously controlled experiment, what we're looking for are things that we think in the forefront might be confounding agents, and therefore we try to group people by these confounding restrictions, and therefore we're hoping to find more about what's going on with that one agent, if there's a difference between this group with this agent and this group with that agent. Now, randomness, we know what that means, right? And randomness will certainly help control confounding because, again, if you're doing something in a truly random manner, then you should be assigning subpopulations, confounding elements equally to all treatment or control groups. Finally, the last thing that we like to do to help control confounding is replication. Now, replication can be several different layers here. Replication can mean that we have just enough individuals within the groups so that we don't get an effect with the confounding because your group isn't big enough to have all the proportions within the group. So that's one way with replication. Another way that replication can come into designing an experiment is repeatability of the experiment. So it doesn't matter if I do it today or if I do it next year or if I do it in 5 years. If I'm using the same population group and the same treatment, I should observe the same things. Doesn't matter when I do it. So that's another way of looking at replication, is basically what we call a repeatability idea. And that is going to end our discussion about designing experiments. Now, there's a whole lot more I could say about designing experiments, but because we're not in experimental design here, we're not taking a class on experimental design, it's really not necessary, and I want you to just have a general introduction to it. So that ends chapter 1.